Till now in mathematical logic, I already discussed proposition, compound proposition, negation, conjunction and disjunction. In today's lecture, I will discuss conditional statement. Let P and Q be two propositions. The conditional statement P implies Q, the symbol is like this, is the proposition if P then Q, and P implies Q will be false if P is true and Q is false, else it is true. And here P is called as hypothesis or antecedent or premises, and Q called as conclusion or consequence. P implies Q called conditional statement as Q is true on the condition that P holds. Q is dependent on P, so that's why it's called as conditional statement. It also called as implication. There are different terminology used for implication, like if P then Q, if P Q, P only if Q. A necessary condition for P is Q. Next, Q if P, Q when P, Q unless negation P. A sufficient condition for Q is P. Just mark here, a necessary condition for P is Q, here a sufficient condition for Q is P. In the first line, first is P, then is Q. In the second line, in all statement, first Q, then P. So you need to mark that connective, like when it's given, then first statement is Q, second statement is P. If unless is given, first statement is Q, second statement is negation P. If is given, then first part is Q, second part is P. So from the compound proposition, you need to identify which part is P and which part is Q. So based on this terminology. Some more terminology are P implies Q, Q follow from P, Q whenever P, Q is necessary for P. So in these three terminology also Q come before P. Let's see some example. If I am elected, then I will load the task. So I am elected is P, I will load the task is Q. So it's in this format. If P, then Q. Let's see one example. Maria learned discrete mathematics, that's our P, and Q is Maria will qualify GET. So P implies Q will be if Maria learned discrete mathematics, then she will qualify GET. So this is P, Q. If P, then Q. This is one format. Another way is Maria will qualify GET when she learned discrete mathematics. Here just mark the term when. And first is Q, second part is P. So Q when P. Maria will qualify GET when she learn mathematics. She learn mathematics is our P and she will qualify GET is our Q. So Q when P. Like this you can write P implies Q in different format. Now truth table for conditional statement. When P true, Q false, P implies Q is false, rest it is true. For P true, Q true, it is true. For P false, Q true, it is true. For P false, Q false, it is true. So only it is false when P is true and Q is false. Next we will discuss contrapositive, converse and inverse. So for P implies Q, its converse is Q implies P. And its contrapositive is negation Q implies negation P. Its inverse is negation P implies negation Q. Here the contrapositive have the same truth value as P implies Q. When two compound propositions have same truth value, we can say they are equivalent. But the inverse and converse are not equivalent with P implies Q. They are equivalent with each other. So we can say Q implies P is equivalent to negation P implies negation Q. So converse is equivalent to inverse, then negation Q implies negation P, it's our contrapositive, is equivalent to the original conditional statement, that is P implies Q. So how will check two compound proposition are equivalent? We can create the truth table. If truth value are equal, we can say it's equivalent. Let's check contrapositive and the conditional statement are equivalent. P, Q, negation P. negation Q, P implies Q, then negation Q implies negation P. Now truth value for P will be true, true, false, false. Then for Q it's true, false, true, false. For negation P it will be false, false, true, true. For negation Q it will be false, true, false, true. Now P implies Q. Here P is true, Q is false. So for P implies Q, here only it will be false, rest it is true. Now for negation Q implies negation P. Negation Q is true, negation P is false here. So for this row it will be false. Rest false implies false, true. False implies true, true. True implies true, true. Now mark the truth value. It's true, false, true, true. Both are equal. So you can say P implies Q is equivalent to negation Q implies negation P, or you can say conditional statement is equivalent to its contrapositive. You can also create truth table for checking the equivalence of converse and inverse. So we found that contrapositive and conditional statement are equivalent and converse and inverse are equivalent, but neither is equivalent to the original conditional statement. Let's see one example of converse, contrapositive and inverse. Here it's written the home team wins whenever it is raining. Just mark this, it's whenever. Q whenever P. That's why I told you this terminology are important. So first part is Q, second part is P. It is raining is P and the home team wins is Q. So you can write if P then Q format. If it is raining then home team wins. If P then Q. Now its contrapositive will be negation Q implies negation P. So if home team doesn't win, then it is not raining. This is our contrapositive. Negation Q implies negation P. So if home team doesn't win is our negation Q, then it is not raining is our negation P. It's equivalent to the original statement. If it is raining, then the home team wins. If the home team doesn't win, then it is not raining. Both are equivalents. Now converse is Q implies P. So if the home team wins, then it is raining. Actually, existence of rain doesn't depend on home team wins. Home team wins existence depend on the raining. So that's why it is not equivalent to the original statement. Next, inverse. Negation P implies negation Q. If it is not raining, then the home team doesn't wins. So this is false. Home team win depends on raining, but it's not that if it is not raining, then it will not win. So converse and inverse are not equivalent with its original statement, but contrapositive is equivalent to the original statement. In next lecture, I will discuss biconditional statement. If this lecture is helpful for you, please like, share and subscribe. Thank you.